Hey gang, it's Phil again. I spoke to you earlier on a video about my career at Sikorsky, so I thought I'd talk a little bit about helicopters. I know many of you have either seen them in the air or some of you maybe have been lucky enough to fly in one. Helicopter is really a unique aircraft. Obviously, it looks different than airplanes that you fly on when you go to the mainland or fly between the islands. But they share a lot of the same aerodynamic principles in order to fly. Um, the helicopter is a very complex aircraft, not only to build, but also to maintain. And it is quite a challenge to fly because unlike an airplane that really just has to rely on a lot of forward speed in order to gain lift, you have to get a helicopter into the air first, and then you have to make it go forward, backwards, sideways, or sideways, depending on what you want to do. So it takes a little bit more work on the pilot's standpoint. From a pilot standpoint, fortunately today, like all your new commercial airliners, most helicopters that the military flies and a lot of the high-end commercial helicopters have automatic flight control systems, which makes it a little bit easier to operate the aircraft. So I'm going to use this model. This was actually given to me when I left Corpus Christi, my last Sikorsky assignment. This was given to me by the depot as a going away present. It's made out of wood, but it's a great representation of a U-860 Blackhawk. So I want to talk a little bit about, well, what makes a helicopter different and what makes a helicopter fly compared to a fixed wing aircraft. So basically on the helicopter, you have a main rotor, which is on top of the aircraft. The number of blades on a helicopter is dependent on the size of the aircraft. Obviously, the smaller aircraft you'll see, like the Robinsons, you see a lot of those flying around back home in Hawaii, only have two rotor blades. The Blackhawk and the Seahawk have four rotor blades on them. You also have a tail rotor. And once again, the type of tail rotor will vary from aircraft to aircraft. A lot of the small helicopters you see flying back home that are used for tours only have two blades back there. Or you have some aircraft that are tour helicopters where you'll see it looks like a shroud and it has a fan instead of a conventional tail rotor. The tail rotor is very important and a unique feature of the helicopter. And I'll talk about why that is here in a sec. So basically the main rotor is where we get our lift from. Now in a helicopter, like I said, you have to get it in the air. So what does that mean? So in the cockpit, the pilot has a set of controls. He has a cyclic stick that is located between their legs. They have a collective stick, which is located on their left hand. That would be used by their left hand would use that collective stick, and then they have two pedals to control the tail rotor. So in a helicopter, to get the aircraft in the air, we have to make all of the blades have the same amount of pitch in them. So what is pitch? So when we want to get the aircraft in the air, we have to change the pitch. Now, hopefully you can see that. I'm changing the angle of the blade. So when we want to gain lift or pull the aircraft into a hover, we're going to put that same amount of pitch in every single blade as it's rotating. All right? So that's going to get our aircraft, and we're going to be in a hover. Now, at the same time that we're doing that, something that makes a helicopter different from other aircraft is I'm in a hover. Now, if I didn't have a tail rotor and I was to put that amount of pitch in each one of these blades, what would happen is the aircraft would want to counteract the rotation of the blades. So our blades are spinning this way, and what would happen is the aircraft would want to go the opposite way. All right. So what's been built into a helicopter to prevent that from happening is the tail rotor. The tail rotor is also referred to as providing anti-torque. So as I said, if we didn't have a tail rotor, as these blades were spinning this direction, the aircraft would want to go the other direction. All right. So by having a tail rotor, we're providing anti-torque to get the aircraft back where it belongs, the nose of the aircraft. All right. So tail rotor has the same thing. Now, I can't do it on this model, but you change the pitch in the blades to achieve the direction that you want to turn the aircraft in. Now, in Sikorsky aircraft, you have to put in left pedal, which would keep the aircraft from going this way. So I'm pulling the aircraft back to the left. All right. When you get into forward flight, when in a Black Hawk, specifically Seahawk, once you maintain an airspeed of 60 knots or greater, the aircraft will have a tendency to slipstream. And even if there was something that happened to the tail rotor, you could still maintain forward flight without the aircraft spinning. But if the airspeed was to come down, then the aircraft would begin to spin if you had a tail rotor failure. So one of the things you, as a pilot, and I did learn how to fly at Sikorsky, is that if I got into a situation in a hover where I lost my tail rotor, the aircraft would want to spin. So obviously what I need to do is reduce the power, right? Take away the torque and get the aircraft to the ground as soon as I can. That's easier said than done when you're in a hover and get that kind of problem. It becomes very tricky for the pilots, and it's usually not a good ending in the sense that there's usually a lot of aircraft damage. Fortunately, in the 860, there's a lot of protections built into the cockpit, and there's a good chance that the pilots would not be harmed. They may get injured, but certainly could avoid death. So when you if you get a tail rotor failure above 60 knots in a Black Hawk, what you want to do is you would perform a run-on landing. So you're going to maintain that 60 knots as long as you can until it's time to set it down on the ground. And that's something that helicopter pilots practice all the time. They practice what's called an auto rotation. Okay, so they will do simulated tail rotor failures. They will do a simulated engine failure. So if you're in an engine failure, one of the things a helicopter would do is, even though the engines quit, the rotor blades will continue to spin. So what happens is you would rapidly descend, and then at the last minute you would put enough pitch into the nose of the aircraft and then settle it on the ground. That's called an auto rotation. Once again, the pilots practice that all the time. Depending on the type of helicopter you're flying, it can be easier or harder. The 860 is a little bit tricky in an auto rotation for one reason. The 860 tends to be a tail-heavy aircraft. Now, what do I mean by that? You can see where the rotor head is on this aircraft, right? So everything in line with that, that's where my center of gravity is. Okay, so the 860 has most of its weight in the back end of the aircraft. So when you see an 860 hovering, you'll notice that most of the time it looks like the tail is a little bit lower. Now, depending on the kind of aircraft it is, you could have a little bit more nose down in a hover, or other aircraft will hover, with a little bit of upward pitch in the nose. But the Black Hawk, Seahawk, the 860 family of aircraft tend to be a tail-heavy aircraft, so they will hover with the tail down a little bit. So back to the tail rotor. That brings us to another function on an 860. This is peculiar to the Black Hawk and Seahawk. The 860 its tail it's not real represented on this model, but it's actually mounted at an angle if this was the real helicopter. It's about at almost a 45-degree angle. Why is that? Because on this particular aircraft, remember I talked about this being a tail-heavy aircraft? When I'm in a hover, I need some way to help keep the tail from becoming even more of a problem. So in a 860 aircraft, the tail is mounted at an angle, so it provides a little bit of lift. So when I'm in a hover, not only is the tail rotor providing some anti-torque, it's providing a little bit of lift to keep the tail up. So what else happens when I'm in a hover? Well, in forward flight, on the H-60 aircraft, you have this item, and it's called the stabulator. When you're in a hover, the stabulator is going to be in a full down position, and the rotor wash from the tail rotor is just going to go down, and this won't be a problem. Now, as we accelerate in flight, the stabulator will start to program itself up to almost a neutral position. And that's the position that it maintains in flight. Now, why do we have that? It's another way to keep the tail from being lower than the nose. It provides a little bit more level flight attitude for the H-60 aircraft. A malfunctioning stabulator can be a catastrophic problem on an H-60. If the stabulator fails to start its upward motion to 0 degrees as you exceed the 60 knots, what would happen is that the aircraft would actually start doing a nose over like that. Now, early on in the Black Hawk design at Sikorsky, we actually had a crash that killed the entire flight crew out in front of our plant in Connecticut because the stabulator did not program like it should have. The pilots accelerated rapidly, and the aircraft just went upside down into the river in front of the factory. Since that accident, a lot of safeguards were put into the stabulator. It's pretty hard to get that kind of failure today for a lot of reasons. You can manually adjust the stabulator now in the cockpit, so a pilot knows if there's a malfunction with the automatic system, and he or she can manually program the stabulator. So it's an important feature on an H-60. You will see stabilators on other aircraft. The Apache has a stabulator that actually works almost exactly the same way that the stabulator works on a Sikorsky H-60. The Apache kind of has the same problem as the Black Hawk does, in the sense that it tends to be a little bit tail heavy. All right, so the stabulator helps in forward flight to maintain that level nose attitude. The H-60s, the newer versions of this aircraft, a majority of the airframe now is made out of composite material. To put it kind of in terms maybe you understand what composite materials are, is they use a lot of carbon fiber. I would liken it to kind of high grade fiberglass, like you making a surfboard back home or paperboard. Most of the airframe now is made of that instead of sheet metal. And that's done for a couple of reasons. One is obviously it's lighter, and in many ways the composite material is stronger than metal. On the H-60, in fact, and this goes back to the original design, the entire front end of the aircraft is actually made out of composite material. And then the tail, back from there to this area here is metal along with the tail boom. Now on the newer versions of the aircraft, a lot of this area has been made out of composite material now. So, as the types of materials get better, those obviously get put into use into the actual production of aircraft. The H-60 has been around. The first aircraft that entered the fleet was back in 1979. So 4 years after I graduated from high school, Sikorsky delivered the first aircraft to the United States Army. I started at Sikorsky in 1980, and at that time, I told you in the previous video, I was a maintenance person and actually helped build the test H-60 that I ended up working on for 2 years. The Seahawk has a different tail wheel configuration. You'll see it in this part of the aircraft instead of on the back. The reason it was put here is for landing on small ships. You have a smaller landing gear footprint, so it's easier to get the aircraft onto the deck. I want to go back to the tail for a minute, because this is something that you guys can look for back home in Hawaii. I'm sure you guys see the Honolulu Fire Department and the HPD helicopters flying around, and you probably look at them after you watch this video and say, I don't see any tail rotor back there. Well, McDonnell Douglas helicopters, which makes the MD-500 that both the HPD and HFD fly, came out with what is called a no-tar tail rotor. And that means that there's a no tail rotor. Sorry for that phone call that popped up. And what does that mean? What does a no-tar tail rotor mean? It means that instead of having a conventional tail rotor like this, if you look at the HFD and HPD helicopter, you'll see that it's got like it's got the tail boom, and it's kind of round in the back, and you see a couple of stabilizers sticking out. What they do is they use airflow over the tail to serve the same function as a tail rotor. So as the air, the side of the tail boom that the air is flowing over changes, that also changes the nose of the aircraft. Now, that's called boundary layer air. Now, I know many of you have probably been on an airplane before and probably looked out the window when you're taking off, and you've noticed that the elevators and the flaps go full down. And then as the aircraft, starts to take off and gains forward speed, the aircraft gets into the air, and then all of a sudden, the elevator and the flaps will retract. Well, what happens is, and it's the same thing with the tail rotor concept, boundary layer air, is you're actually blowing air over the airfoil to cause a reaction. So if you were to take a strip of paper, put it underneath your lip, and blow air over the top of it, what you would see is the end of the paper would lift, all right? That's the same thing that happens on an airplane wing when you're flying. The air is flowing over the top. It's the air flowing over the top of the wing that causes the lift. So with the boundary layer air concept, it's the same idea. We're going to force air over one side of the tail boom or the other. That's going to cause the direction. So that's kind of a cool thing. Next time you see one of those aircraft back home flying around, you'll understand why they don't have a tail rotor. Now, there's pros and cons to that type of tail rotor. One of them is that you're a little bit limited, especially on a hot day, because of the amount of torque that's required. And that's torque is affected on all helicopters, depending on your elevation and how hot it is outside. That affects how the engines operate, right? So no TARs, primarily right now, it's just McDonnell Douglas that uses that kind of tail technology. But it's something that's been tried by other companies. Sikorsky has never gone to the boundary layer air in a tail rotor. However, back in the early 80s, when I first started at Sikorsky and NASA was working on an aircraft that used that same concept for the main rotor blades. So what could happen is that the blades would function like a regular helicopter up to a certain speed. And if we wanted to go faster, the blades actually stopped. And the same concept was used blowing air. There were slots in the front, the leading edge of the rotor blades, and they would use air to provide the controllability of the aircraft. Just like McDonnell Douglas uses it on the tail here, they would use boundary layer air on the tops of the rotor blades or over the rotor blades to change the pitch of the aircraft. So the helicopter is a pretty complicated piece of machinery. It gets a bad rap in the press. I know back home a lot of people complain about the tour helicopters because they have a lot of accidents. I can tell you that most accidents in helicopters are pilot error and not due to mechanical issues. They're actually a very safe aircraft. Probably the most notable accident here recently that happened that the whole world was stunned with was Kobe Bryant. He actually was in a Sikorsky S-76B aircraft when that accident happened. Obviously they're still doing an investigation on that. But I can tell you, as someone who has flown in that area, in foggy conditions that it is dangerous, and generally speaking, you have to revert to an instrument flight to finish a flight in that conditions in that area. So, the NTSB will come out with the report, I would assume within the next few months, and we'll find what happened. I know as soon as that accident happened, I really took it to heart because I saw so many posts on social media about how dangerous helicopters are and all that without anyone really understanding what happened in that accident. I would say from my perspective, and this is Phil speaking, I have no knowledge or anything, but it's more than likely that accident was caused because of poor pilot decisions. I think some of that's been bared out, even without the final report that's been laid out. So I guess what I'm trying to say is, the helicopter's not a dangerous machine. In fact, myself, I feel safer in a helicopter than when I get in my car every day. I got a better chance of getting killed in my car than I do in a helicopter. So don't be afraid of it. They're fabulous machines. Igor Sikorsky, who really was the father of the modern day helicopter, put a lot of time and effort into trying to figure out how to make the helicopter work. I have a great story about Igor Sikorsky. Now, I never got to meet him, but I did work with his son, Sergei Sikorsky, who was a vice president at Sikorsky Aircraft. But anyway, when Igor was working on his prototype helicopter, the VS-300, he had done a lot of work, but he needed some more money from bankers to continue on with his work. So Igor got all these bankers together one day and was going to do a little bit of a flight demo for him. So Igor, who many of you, I don't know if you know who Igor Sikorsky is, but when you see pictures of him, he's always got a fedora on, and he actually always flew his helicopters with no cockpit with a fedora on. But anyway, on this particular day, Igor went out and needed some more money to continue working on his designs. And so he got the aircraft out there amongst all these bankers, and he pulled it up into a hover and set it back on the ground. And all of the people thought, wow, that's really great, and they said, well, okay, Mr. Sikorsky, we're going to give you some more money to work on this. Well, what Igor never told him was at that point, he had not perfected forward, backward, or sideward flight in the helicopter. All he had perfected was the hover mode. But the rest is history. Igor got his money. He went on to build a helicopter that is world renowned. The 860 is flown around the world by numerous countries, military aircraft. And it's really one of the safest helicopters in the air. It was designed to be safe after all of the lessons learned from the Vietnam War on the old Hueys that you still see flying around once in a while or on TV. A lot of safety features were put into the 860. It's really been a privilege for me to be a part of that and a part of naval aviation history, having worked on the test program. And still see the aircraft today. Obviously, they've taken on a lot of modifications, but they continue to be the workhorse in the Navy and the workhorse in the Army. So I hope you got a little bit out of this. I know this is kind of threw this together at the last minute. I can tell you one thing. I'm getting ready to turn 63 years old in 2 weeks. But my love for helicopters hasn't changed. I'm still a kid in a candy store whenever I see one flying around, or whether I'm around one, or I haven't been able to fly one in a few years. I would love to get back into flying again. But they're magnificent machines. And if you ever get the chance to fly in one, or decide, hey, I'd like to pursue a career in flying, a helicopter is a wonderful machine to be a pilot of. I know the military today is short of helicopter pilots. In fact, there's a worldwide shortage of pilots. Now, some of that is going to be tempered right now because of what's going on with the pandemic, with all the aircraft that are grounded. But if things were all normal, like they were 4 weeks ago, there was a real shortage of pilots, and there still is a shortage of pilots in the military. The last count was around, for the Army, was somewhere around 450 helicopter pilots they were short. So something to consider, whether you do it in the military or learn how to fly on your own. Helicopter's a pretty cool machine. So anyway, I hope you guys got a little bit out of that, and good luck with the rest of your school year. And if you guys ever have any questions about anything about Sikorsky helicopters, please feel free to let your teacher know, and she'll get a hold of me, and I'll be able to answer the questions for you. All right, take it easy.